All right, so we are back, and where I left off in the last video was talking about this example of how this table, which I made into a graph, is a function. So every input has exactly one output. So to compare then to what a graph looks like, or a graph of coordinate points that is not a function, I'm going to go ahead and divide up this graph again into as many even segments as I can. So it looks like I can get about 5 along the x-axis and the same on the y. So I'll make 5 hash marks as evenly as possible as I can. All right, then I'm going to go ahead and graph these points. I'm going to graph -3, 0, -2, -1,
Mommy.
-2, +2, -1, 0, 1, +2, 2, -1, 4, 0, 4, 3, and 4, -2. So now that I have my new graph here, again, I'm going to grab my ruler, my green highlighter, and I'm going to go ahead and draw those vertical lines and attempt to do the vertical line test to see whether or not this is or is not a function. So I'm going to put my ruler and I'm going to put my first dotted vertical line through the first coordinate point. Then I'm going to find my next coordinate point and put a dashed line or a vertical line through that. And if you notice, I have 2 coordinate points that this dotted vertical line is going through. So that's one spot. Then the next dotted line will go through this point. Then I have a point at 1, 2, so I'll draw my vertical line through that. Point at 2, -1, draw my line through that. And then finally, I'm going to draw my vertical line, which looks to hit 3 coordinate points right in a row. So this graph is an example of not a function, or is not a function, because in 2 spots, here on the negative side of my x-axis and here on the positive side of my x-axis, in these 2 spots, my vertical line goes through 2 or more points. This means not every input has exactly one distinct output. So this is why this example is not a function. Let's go ahead and move back to the function side. I'm going to go ahead and draw what's called a piecewise graph, or a piecewise function per se, because it's going to be a function. And we're going to see how this graph compares to the graphs that I drew up above. So I'm going to go ahead and divvy up my graph again by, let's see what I can fit, by 5s. So get 5 hash marks on each of my axes. And then what I'm going to do is at -3, 2, I'm going to draw what's called an open circle. Mom, and then my graph is going to be kind of up and down. Sorry, that's my daughter. So this part of the graph, open circle, and then I continued on in this direction, and it's kind of got this wave to it. And then at -3, 3, I'm going to draw another coordinate point, but this time I'm going to circle it in. And I'm then going to go ahead and continue the graph. So it kind of goes in this direction. So it starts in an upward direction or in an increasing direction, and then it gradually decreases. And I put an arrow at the end here, so it's going to gradually decrease over time. So this is what we call a piecewise function, or a piecewise graph, I should say, because what I have here is not necessarily 2 separate graphs, but I have 2 parts of my graph. This one has an open circle and the graph continues to the left in this direction. And then on top, it has a closed circle and it continues on to the positive side of the x-axis. So if I did my vertical line test, again, taking my ruler and my green highlighter, I'm going to go ahead and draw a bunch of vertical lines through this graph. So there's one, there's one, There's one. I'll put one through these 2 points. And then I'll just keep going as I move along the x-axis here with my ruler. So again, I'm keeping on drawing these vertical lines. And as I get towards the end of the function on the right-hand side here, I'm going to go ahead and stop. But when I look back at the vertical lines that I drew, I can tell that none of my vertical lines pass through 2 points at any given time. Now, you may be wondering, well, Mrs. Shattuck, there's clearly 2 points right here, one at -3, 2, and one at -3, 3. And I agree with you, there are 2 coordinate points. However, one has an open circle and one has a closed circle, which matter. So the reason why this matters is because the closed circle here means that this graph, or this coordinate point, is part of this graph. It's a solution to this graph. The open circle here is more of an endpoint. It's part of the graph, but the value is not part of the graph. So it's just kind of like a placeholder. And so even though this vertical line goes through these 2 coordinate points, technically it's only going through 1 coordinate point on the graph because only one of the points is closed in. Therefore, this is a representation of a function. So to contrast or to compare, over here I'm going to go ahead and draw another coordinate plane. So you're going to have to go ahead and do that yourself. Getting used to, again, this is a quick sketch. So remember, for like your practice problems or on your summative assessments, whenever I ask you to graph, I'm going to actually have you graph on graphing paper. So it's a more accurate representation of what it is you're graphing. But just getting used to drawing the x and the y axis, where they go, as well as just setting up a coordinate plane in general is helpful. So this time I'm going to go ahead and I'm going to draw a circle graph. Circle's not the best, so don't make fun of me. But again, then I'm going to grab a ruler and I'm going to draw a bunch of vertical dotted lines through this graph, or through this circle graph, I should say. And as I go ahead and draw these vertical lines, you're going to start to notice that wherever I have the vertical lines drawn, my vertical lines go through the circle in at least 2 places. And because there is no open circle or open endpoints to this graph, I can clearly see that this graph does not pass the vertical line test. Therefore, this is proof that this graph, or circle graphs, are not functions. Again, they're graphs. They show a relationship between inputs and outputs, but they are not particular functions. So then finally, so to go back through, I guess, I gave you an example of a function and a not function by just looking at coordinate points. I gave you an example of a function or not a function by looking at particular graphs. Now in the bottom section here, I'm going to go ahead and list a bunch of different equations or functions to show you how functions look when we are comparing whether or not they're functions from non-functions. So on the function side, I'm going to go ahead and write the equation y equals -2x, f of x equals 4 minus 2x, and f of x equals x squared plus 5x minus 1. So with these functions, or equations I should say, they are all functions. So if you were to, I don't know, let's say go on to Desmos.com or GeoGebra.com, or maybe even make a table, you would see that every input has exactly 1 output for these equations. So these equations or functions are representations of actual functions. An equation that is not a function would be something like y squared plus x squared equals 7. This function is like a circle graph, and so that's why it is not a function, because it will not pass the vertical line test.